Hello, and welcome to my channel. I am Snacks the Druid, and today I'm going to be introducing something I call digital compounding. Now, this is just an introduction video. I'm hoping to keep it short and sweet because, quite frankly, I've got other videos that I would rather make that have piqued my interest more. I mean, this process piqued my interest a while ago, and it still does because there's some interesting things about it. But the reason I want to showcase it is because it kind of shows one of my primary motivations towards doing any research in a number basis, which is what I want to make the primary focus of my channel as far as mathematics and numbers are concerned. And it's this process, digital compounding. What is it? So you take any two-digit number and you take the tens place and you take the ones place and you add them together. And then you take that number, the sum, and you add it to the ones place again. And then you keep adding the sums until infinity. Calculus bros, if you want to post an equation or process that makes it simpler to understand what's going on, do so in the comments. But anyhow, so like you have 0 and 1. So 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, and so on and so forth. That's the Fibonacci sequence. But the Fibonacci compound is what I'm calling this. And the real kicker and why I think this process is interesting is because there are 7 different ways to make this specific sequence. You can go 0, 1, 1, 0, 1, 1, 1, 2, 2, 3, 3, 5, and 5, 8. Why would you want to do this? I don't know. Maybe you want the sequence to start at a different position. It's just kind of something, I guess. But you got all the numbers from 0, 1 down to 10. And so you can see this and this are fundamentally the same. It's just this one is slower than that one. And I call these ones the base sequences because they start with 0 and they're kind of like the foundational digital compounds. I've got 3 other classifications, but I'm not going to do them in this video. If people are interested and want to see them, please leave a comment saying that you'd like to see me try to explain stuff about them. But I just really wanted to highlight my main piece of interest in this process is that these numbers go on towards infinity, and people who have been on my channel know that I like the digital root process. I think it's interesting. I am interested in numerology, as a lot of Enlightenment math people were also. Newton, Leibniz, pretty much anyone who studied number theory probably had some level of numerology, but there's also like applications for like Jewish Kabbalah, Mesopotamian magic, Indian, Hindus, Arabs, the whole 9 yards of those ancient cultures and their mystic little secret practices. But anyhow, you process this all the way through, and then I took a program on Python and broke down the digital roots of all the numbers that generate. And so basically how it breaks down is you have all the numbers that can possibly be. But there are 2 numbers specifically in each sequence that rate 20% higher than everything else. So for the Fibonacci sequence, if you broke it down to 1,000 places, about 20% of all the digital roots generated are going to be 8 or 1, and the rest are going to be relegated to 5%, I think. That's how it works out. But it's like an egregiously higher amount. And if you do 2, it goes to 7 and 2, 3, 6 and 3, 4, 5 and 4. 5 and 4, 6 and 3, 7 and 2, 8 and 1. So it kind of like recurves back on itself. And then you have 9, and the 9 compound is only ever going to generate digital roots of 9 because that's how 9 works. And so I guess my long-winded roundabout thought process on this is what this does to me and what it suggests to me is that there's some grander form of quaternary. Because if you take digital roots of, let's say, 7 and 2, so 2, 4, 6, 8, 10 is 1, 12 is 3, 14 is 5, 16 is 7, 18 is 9, right? But if you take 7, you go 7 plus 7 is 14, which is 5, plus 7 is 21, which is 3, plus 7 is 28, which is 1, and so with 2s, you're going forwards by 2, and with 7s, you're going backwards by 2. And so that's kind of why they show up in tandem like that, the way that they do. But like I said, this is because this kind of pattern showed up, and if you divide it out and level it, you've got 4 different options, plus a 0, which to me kind of like suggests some level of quaternary or quinary, I think is space 5, that maybe nobody has really picked up on. I don't know. Regardless, it was my motivator for a lot of my studies into this kind of stuff. And I've got a lot more that I'd like to talk. But like another interesting thing, the reason I included 10 is because all these, you know, you're going to see the Fibonacci sequence redone. And if you took a Microsoft Excel spreadsheet or Google Sheets, if you want to, and you did this process 0, 1, all the way down to 99, you would find that this process continues where it goes +1 all the way down. And then when you break, it subtracts 8. And then when you break, it subtracts 17. When you break, it subtracts 25, 42, 67, 109, 176, 285, 461, which an interesting thing about 461 is it's the 89th prime number. I don't know. It's fun that it shows up before the, like, you know, +89 bracket, I guess. But more interestingly enough, if you take the digital compound of 98, you know, 9 plus 8 equals 17, 17 plus 8 equals 25, and so on and so forth. The 98 sequence or compound creates this pattern perfectly, and I don't know, it's interesting knowing as well that 98 is 49 times 2. Well, I don't know, that's what I think is interesting. It's a pretty dry video. I've been dreading making this because I get more interesting things, but again, before we get into my weird number bases that I've worked on, you have to understand that this right here was my primary motivator, is that they only ever show up in these twos. So if it's an 8 and 1, it always shows up like that. If it's 7 and 2, it always shows up like that. 6 and 3 always shows up like that. And that's true for every single one of these compounds. And let me show you one thing as to what I think is interesting on this. Okay, so up here I've written what I call compound 12. And compound 52. And so one of the things that I noticed when I looked at this, and the reason that I came up with this one, I call it the Stirling sequence because it's excellent. But I was looking at the snack sequence and it seemed like things were pretty much concocted of like 4-digit sequences. So like Fibonacci sequence, if you take 1 out of the equation, it's 2, 3, 5, and 8. Because I don't super consider 1 a number in a very abstract sense. Like I get it, you count with it, it's a necessary component, but it's a measurement is what I think. Because when you say 1 of something, you've quantified it. There, that's the basics of it. So you can have like 1 inch and 1 centimeter, but those ones are different. However, like then you get into the counting numbers. So, and that kind of line of thinking goes with a lot of ancient Greek mathematics and Arab mathematics as well, just kind of like in theory and philosophy. And so that's my stance. I get it. 1 is a countable number, but it's also a very complex number because, you know, 3 over 3 is 0.9999999. But anyhow, so the reason I call this a Stirling sequence is because it's excellent. So you go 5, 2, 7, and then you get 9, 16, 25. So you get the 3 squared, 4 squared, then 5 squared. And I think that was interesting when I saw it. But anyhow, I thought this looked to be about 2 times that. I don't know, it's kind of a weird thought. So what I did was I went 2, 4, multiplied it over the line, 6, 14, right? What am I thinking? That's 10. 16, 26, 42, 68, 110, 178, and then 288. And then I was like, all right, cool. Well, let me subtract now. And so you get -3, 2, -1, 1, 0, 1, 1, 2, 3, 5, 8. And so it just presented this weird situation where it kind of like goes negative, goes positive, goes negative, goes positive, and kind of like balances and equals out to that 0, and then progressively does the Fibonacci sequence. And I'm not trying to claim anything by that. This is, I think, a superposition in and of itself because it creates that 0 that kind of goes through it, but I don't know. It's just something interesting, I thought. Anyhow, I'm going to get to other content now. Please like and subscribe, comment, have fun, live your life. Thank you.